Okay guys, once again you are welcome to my YouTube channel. So today we are going to be talking about differentiation by product rule, or differentiation using product rule, and which is a very simple thing. If you don't know anything about differentiation, you can check my past videos and you'll see a lot of differentiation videos where I exclusively explain about differentiation. Okay, so we have different techniques for solving differentiation problems, and one of them is differentiation by product rule. So what this basically means is, when you have, let's say, u and v multiplying each other, and they are both functions of, where u and v are functions of x, let's say that is, u is a function of x and v is a function of x. It means they are both functions of x, right? In the case where they are both functions of x, the y over the x, which is basically the slope or the gradient function, is going to be u dv over the x plus v du over the x. And I think this is a very simple formula. So basically, this is our product rule. This is our product rule. Okay? But I have a much more simpler formula to use. Let's assume let's say y is equals to f of x multiplied by g of x. Let's say these are two different functions, two different variables which are dependent on x. So let us take the first example here, which is y equals x cubed sine 5x. Okay, so how do you actually go about this? How do you know that the rule we are supposed to use here is product rule? It's actually very simple. You have x cubed here is one variable, and you have 5x here is actually another variable, but they are both functions of what? X. Then you use product rule. Mind you, whenever you have something like this, y equals 2 sine 5x. Now there's a variable of x here, but there's no variable of x here. So here is just a constant and not a variable. So for that reason, you cannot use product rule on this. Instead, you use chains rule. Okay, so you cannot apply product rule here, while you can apply product rule here. Why? Because these two variables are functions of what? X. There's an x variable here and there's an x variable here in two different functions. So when two different functions are functions of the same variable, that is when you apply product rule. So we are free to apply product rule here based on our definition of application. Okay, so let's proceed and use product rule. Okay, this is going to be very interesting. So like I said, so in this situation, x cubed is like our f of x, while sine 5x is our g of x. Okay, now all we just have to do is to substitute it into this formula and we will get our answer. Okay, so let's do that. So all you have to do is to bring the first term down. The first term here is x cubed. In that case, the y over the x, because to bring the first term down, which serves as our f of x, you differentiate the second. The second one here is x is sine 5x. I believe you all know how to differentiate sine 5x. If you don't know how to do that, you can check on my chain rule videos and actually learn how to do that. Now, differentiating the chain rule, what you first of all do is differentiate the outer function. The outer function here is sine. If you differentiate sine, you will get cos. So first of all, we have cos there. But in chain rule, you differentiate the inner function first, which is, if you differentiate 5x, you get 5. If you differentiate sine, you get the outer function now, you get cos. Then you replace the inner function back. And we are done with differentiating this. So this is basically chain rule. So we are done with So what we did here is that we brought the first term down, differentiated this. So what we're going to do now is bring this one down and differentiate the first term. So what do we do now? Differentiate the first term. Differentiating this will give us 3x squared. 3 down, 3 minus 1, and it gives us 3x squared. Then we bring the second term down, sine 5x, without differentiating it this time around. So, and I believe it's very clear. Bring down the first term, differentiate the second one, plus differentiate the first one, which is this, and bring down the second one without differentiating it. And it's as simple as that. Now we can further simplify. Since these are actually our answer, you can leave an answer like this depending on what your teacher wants you to do or how your teacher wants you to represent it. Okay? So, but there's an x squared here, there's an x squared here. We can factorize it out. So since an x is left here, we have 5x cos 5x plus the x squared is out. So all we have here is 3 sine 5x. And we can leave our answer as this. Hence, the y over the x is equals to x squared 5x cos 5x plus 3 sine 5x. And I think we are done with our answer. It is this simple. Okay, so I believe with the first example we've done, you can try this. Let's say we have y equals x squared tan x. Okay, and we are asked to differentiate this with respect to x. To x, right? So from our rule, we said we bring this down without wasting time. Bring this first one down, differentiate this. If you differentiate tan x, I believe you should all know that by now, that you will get sec square x plus this. Now you are done with the first stage. The second stage is what? You differentiate the first one that you did not differentiate before, and to give you 2x, and I believe you all now got that 2 comes down, 2 minus 1, and it gives you 2x. And this time around, you bring the second one down without differentiating it. Okay, so in this case we have x squared sec square x plus 2x tan x. But meanwhile, we have a common term in the both of them. We have x here, we have x here, so we can bring x out and say, okay, here we'll be left with x sec square x plus 2 tan x, and this is our answer. So I would like you to solve the next one by yourself. If you could utilize this formula, you can see how simple product rule is. Okay, so let's apply it to another question. I would rather prefer you to pause this video and attempt this question yourself. X to the power of 5 exponential x. Now, if I have to differentiate this with respect to x, so how do you go about this? Please feel free, pause the video, try it yourself, and if you don't get it, we can solve it together so that you can get it right. Okay, differentiating this with respect to x, like we said, bring down the first term, x to the power of 5, dot, you differentiate this. Differentiating exponential x or e to the power of x still remains e to the power of x. By now you should know your standard derivatives, and if you don't, I will write them down for you so that you can get to know them better. Okay, so but I believe before watching this video you should have learned your standard derivatives so that differentiating will be very easy for you. Okay, so standard derivatives are actually a table of derivatives that are already differentiated. Okay, so we have differentiated the first one, we have brought down the first one, differentiated the second, plus now we differentiate the first one, which is going to be 5x to the power of 4, because 5 comes down, then 5 minus 1 gives you 4. Then we bring down the second one undifferentiated. Notice or take note that exponential x when differentiated gives you exponential x. It doesn't change. Okay, so meanwhile exponential x is common to both of them, and x to the power of 4 is also common, so factorize the both. So here we have x to the power of 4 and exponential x, open bracket, and x will be left if we factorize this, plus what? 5. This is actually out, so this is going to be our answer, right? X to the power of 4 exponential x plus 5. You can see how simple this actually is, right? Okay, let's take this one that looks more complex. Say y equals x squared, open bracket, 2x minus 5 to the power of 4. Differentiate or find the derivative with respect to x. Mind this stands for with respect to x. Okay. Now, somebody is already scared and feeling like this is actually complex, but it's not really complex. It's actually a simple problem. Okay. So, how many functions are here? We have 2 functions here, and let's take this one to be what? F of what? X, and let's take this one here to be what? G of what? X, and we apply our formula. It's as simple as that. Okay. Now we have the y over the x is going to be what? Remember, the first one, we bring down the first one, which is x squared. We differentiate the second. Okay. Now from our chain rule, like I said, if you've not watched my chain rule video, please do well to watch them so that you can understand how to do this very easily. Okay, but let's differentiate this using chain rule. In chain rule, differentiating this will be, you bring down the power 4. Okay, you differentiate what is inside. What is inside is 2x plus 5. Differentiating 2x plus 5, you have 2, right? The power comes down, you differentiate what's inside, you drop it. Then you rewrite what is inside, 2x minus 5, then minus 1 from the power. 4 minus 1. It's just like your normal product, your normal power rule, where you bring it down, bring the power down, multiply with the coefficient, and minus 1 from the power. Similar to that. That's what you do with chain rule whenever you have something like this. And meanwhile, when you use chain rule, you use chain rule when you have a function inside of another function. Okay, so what you have here is actually 8, open bracket, 2x minus 5 to the power of 3. 4 minus 1 is 3. So if we differentiate this is what we're going to get, right? So we say differentiating that, we have what? 8, open bracket, 2x minus 5 to the power of 3. Now we brought this down and we differentiated the second term, plus now we differentiate the first term, which gives us 2x, because 2 comes down, 2 minus 1 gives us 2x. Then we rewrite our second equation like that, 2x minus 5 to the power of what? 4. Now we could leave our answer like this, but we have common factors that we can bring out. Okay, we can choose to leave our answers like this or choose to simplify further, but it will be better if we simplify it further, right? Okay, so what we are going to do here is, there's 2x minus 5 here to the power of 3, and there's also 2x minus 5 here to the power of 4. So it means 2x minus 5 to the power of 3 is common to this and this, right? Okay, so bring it out. We can bring 2x out here. The 2x can go into this and 2x can go into this. So we have a common factor of 2x, open bracket, 2x minus 5 to the power of 3, right? Now, if we pull out this from this, we get what? 4x. 4x times 2x will give you 8x squared, right? And what is left here is gone. Plus, if you pull out this from here, 2x minus 5, 1 will be left. 2x minus 5 will be left. Okay? And we'll have 2x, open bracket, 2x minus 5 to the power of 3. 4x plus 2x gives you 6x. And I think we can leave our answer like this. Okay? This is actually a good way of leaving your answer. And you can see that this is actually very, very simple. Okay? So, a quick recap. You should remember that you can only use product rule when you have 2 functions with the same variable multiplying themselves. F of x is a function, g of x is a function, but they have the same, but they are functions of the same variable x. They are both functions of x, and that is why we can apply product true. And I said earlier that you cannot use product true when you have a constant multiplied by a variable. Okay, whenever you have y equals 2 pi, open bracket, let's say x plus 1 to the power of 3, just take note that you cannot apply product true here because, first of all, pi is a constant and not a variable. You get, right? Pi is a constant. Mathematically, pi is equals 22/7, right? Or 3.142, right? So it's a constant.